Yep, that's me. You can call me OG. And this morning, my job is to pretend to fall asleep while driving. Hey, good morning. Now, everything goes fine. And this happens.
Bro, you dey sleep, you dey drive, you dey sleep. Abeg bros, wake up jare.
Hi guys, this is the first episode of our new series, the Creatronix series. In this new episode, I'll be exploring how to build an anti-sleep system for a car. The whole idea for an anti-sleep system is to help a driver stay active and engaged while he's operating his vehicle and to prevent him generally from falling asleep. So, the anti-sleep system is going to be based on image processing technology. I'll be showing you in this episode how to implement different image technology for this project, and I'm hoping that you have a nice time watching this video. So if you're ready to build, so come on, let's go build.
Alright, so here's my car. Okay, so it's a Saturn View 2005 car. So let's go in and let me show you some of what we're going to be looking at for the project. Okay, so I have a phone holder that I want to use, where I'm going to mount the Raspberry Pi on the phone holder. And you can get this off Amazon, or if you're in Nigeria, you can get it off Konga. And also, to power the Raspberry Pi, we'll need a 5-volt. Okay, so we're going to use output from this point here. It's actually 12-volt output from the car battery, and this output here is going to give us 5 volts, which we're going to use for the Raspberry Pi to power it up. Okay, so that's just basically what we will need. We just need the output from this point, and you just need the phone holder. That's what will be needed to mount the Raspberry Pi. Okay, so I'm going to go show I'll show us some of the items that we're going to be using for the project. Okay, so come on, let's go look at it.
Next, still to come.
So you're gonna need a Raspberry Pi. Here's the power supply. It comes with a power supply. Comes with the HDMI cable which you may need to put to a screen. Then it comes with a couple of other stuff that it comes with. It also comes with an Ethernet cable where you can use for network to you want to put a LAN connection to the. The Raspberry Pi comes also with Wi-Fi and a couple of other Bluetooth and other stuff. So, but the Kana kit is very, very good. If you can get the Kana kit, you can lay your hands on it. It's maybe quite pricey, but it's worth the buy, because it comes in with all the different things you will need to get set up your Raspberry Pi. So you would also need a 5-inch LCD screen like this. We will need a camera like this. This camera is called the Raspberry Pi Cam, or Raspberry Pi Camera version 1.3. You can get it off Amazon, and it's very good. It's a 1080 pixel camera, wide range for wide range view and field of view, and you can get very, very good output from this camera. That's what we're going to be using for the detection. We'll also need the power supply for our car. So that is what I'm going to be using. This one comes with it's actually, you could calibrate with different voltages. Okay, so I don't know if you can see this, but you can see that it's set to 5 volts, which is for the Raspberry Pi. So these are some of the items that we will need. I think also we will need a buzzer, and I have a buzzer for the output for the voice. We want to output audio from the Raspberry Pi, especially when we detect let's say detect sleepiness. We want to be able to show that and give an output sound. So you could use a speaker, like a speaker or a beeper that you can use to attach via USB here. That will depend on you. Okay. For me, for this project, I'm using some speakers. I'll show you in a moment, which I'll be using here. So there's going to be an output from here, from the 3.5mm audio jack of the Raspberry Pi. So the Raspberry Pi requires a micro SD card, like you've seen here. The SD card, usually this SD card is already loaded. So like I said, you can check it online and see how the SD card is loaded. You usually would use an SD card reader, with the with this micro SD card, and which you can use. You can use an SD. You can use a USB SD card reader, which you can insert into your PC. Then you can run some software. I think the software I use is the Etcher. You also need from the Raspberry Pi.org website, the website for Raspberry Pi. You can download the Raspbian Stretch operating system, and it's actually an image, so you would need that, and you would load it using the Etcher IO software, and you will load it into the micro SD card. And when you successfully loaded it, you can just insert here like that, and you're good to go. You just power up. Okay, so here I have the power supply, which would easily go into this point. Let's see. Okay, I've just inserted it. You don't power yet. I'll just go ahead and put also the HDMI cable, and I'll also insert the USB keyboard, and the USB mouse will go in here. Okay, so I've just plugged in the HDMI cable that went in here. So here will require a VGA cable. Okay, and this is the VGA cable. This VGA cable will go in here like this. In recent years, computers have advanced and have bagged great accomplishments. Ever wondered how former chess grandmaster Garry Kasparov was defeated by a computer in 1997? Ever wondered how Google's AlphaGo computer defeated 18-time South Korean world champion Lee Sedol after a 5-game Go match? You ever wondered how your email is targeted with specific media content by advertising companies? When you delve deep to find out how that is even possible, you'll soon discover some words appearing frequently. Words like artificial intelligence, machine learning, deep learning. Artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. Artificial intelligence is usually implemented in a computer system. The goal of artificial intelligence is to simulate natural intelligence to solve complex problems. AI is used mostly for decision making. AI always seeks to find optimal solutions to problems. Machine learning is the learning in which machine can learn by its own without being explicitly programmed. Machine learning allows systems to learn new things from data. And usually machine learning will lead to knowledge. When should you use machine learning? Machine learning is usually used when you have a complex task or problem involving a large amount of data and lots of variables, but no existing formula or equation. For example, machine learning is a good option if you need to handle situations like these. Deep learning. Deep learning is a specialized form of machine learning. A machine learning workflow starts with relevant features being manually extracted from images. The features are then used to create a model that categorizes the objects in the image. With a deep learning workflow, relevant features are automatically extracted from images. Rather than extracting these features manually using some filters, deep learning automatically gathers these features based on the amount of image data gathered. But in machine learning, these features are extracted manually. The three most common ways people use deep learning to perform object classification are training from scratch, transfer learning, and feature extraction. Now, back to our project. For the anti-slip project, I have loaded a TensorFlow image on a Docker container to run and test my TensorFlow applications. Docker is a software that is running on my Windows PC. In this first attempt, I intend to train a classifier to be able to detect images of a person that is sleepy or drowsy. So, I have gathered enough images which I've categorized into three: control, random, and test. The control folder contains images of people that are sleepy or drowsy, or we can also call the control folder positive sample images. The random folder contains images which includes ball, shoes, pen, everything else except images of people that are sleepy. Or we can also call the random folder images, we can also call them negative samples. The last category is the test folder, and this folder contains a mixture of positive samples and negative samples. When the classifier has been trained, these test images will be used to test the classifier to see how effective it works. So, I have just trained the classifier, or also called the sleep detector, with images of drowsy drivers. Next, I want to test with this image. In this image, my eyes are open and I'm expecting drowsiness to be low and random to be high. Let's see.
Come on, man. Oh no, come on, man.
Actually, the goal of this project, the anti-sleep project, using TensorFlow is not to train a world-class anti-sleep or drowsy or alert system, but to get something, no matter how dirty or jerky, but functional, to show generally that it works. That's the whole intention and aim for this project.
Yeah, got it working. Really?
Next, still to come. I have speakers that I got from Amazon. So they're Amazon speakers. So it's a double speaker. Okay. just power up to the 3.5 mm audio jack of the Raspberry Pi so we can get some sound, okay? Poof. Imagine my frustration after weeks on using TensorFlow to train a sleep detector, and still I was greatly dissatisfied because of the very high false positives or false alarms on my sleep detector. So, after checking the internet some more, I came across another way to build a sleep detector, this time using facial landmarks. Facial landmarks, based on Python's programming language Dlib library, uses a 1 millisecond face alignment with an ensemble of regression trees to implement this feature. The library uses a facial training set to understand where certain points exist on facial structures. The program then plots the same points on regions of interest in other images if they exist. The library outputs a 68-point plot on a given input image. So, to build my sleep detector using facial landmarks, it will start by first detecting any faces in an input image or video feed. A face detector detects faces in a digital image, and one of the very popular face detectors is the Viola-Jones face detector, which will be used in this project. The face detector returns a bounding box or boxes of areas that contain a face or faces. A typical face detection starts by loading the image to the computer memory and then using a scanner to find faces. The scanner uses hard rectangle features, or simply called filters. The scanner moves quickly through the image pixels looking for faces in every scan area. At the end of the scan, if no faces are found, the scanner returns to the very beginning of the image location in the computer memory, and this time enlarges its size and enlarges its scan area. This is done repeatedly so as to find small faces as well as large faces in an image. Next, facial landmark detection is applied to the face found and the eye regions extracted. Once the eye regions have been obtained, the eye aspect ratio is computed to determine if the eyes are closed. If the eye aspect ratio indicates that the eyes have been closed for a sufficiently long amount of time, the alarm is sounded to wake up the driver. The eye aspect ratio is computed based on the ratio of distances between facial landmarks of the eyes. In terms of eye blinks, I am interested in two sets of facial structures, the eyes. Each eye is represented by 6 XY coordinates. So, I'll pay attention to points 37 to 48 for the eye regions. The eye aspect ratio is approximately constant while the eye is open, but will rapidly fall to 0 when the blink is taking place. Next, I get to run a series of tests on my new sleep detector using facial landmarks and see how it performs. During testing, to be candid, I was pretty much satisfied with the results of the facial landmark sleep detector, as it had very low false positives compared to the TensorFlow sleep detector, and it had much better performance as expected. Of course, there's still more work to be done on the sleep detector, but sure enough, I can use my new sleep detector and I'm pretty much happy about that.